Hello friends, welcome to the video lessons on electronic measuring instruments. In today's class, I will discuss about differential voltmeter. We will see what is the use of differential voltmeter and what is the basic circuit of differential voltmeter and how it functions. Then what is AC differential voltmeter and what is the standard mode of differential voltmeter and differential mode of differential voltmeter. But before we proceed to this topic, let us try to recollect what we have studied in the last class. In the last class, we studied about electronic measuring instruments and working of FET input voltmeter. Electronic instruments are similar to electrical instruments like voltmeters, ammeters, ohm meters, etc. But in addition to the basic circuitry used in electrical meters, in electronic meters or electronic measuring instruments, additional circuitry like amplifiers, attenuators, wave shaping circuits, that is signal modifiers, are used in electronic measuring instruments in order to make sure that the sensitivity of the device becomes very high. Input impedance is very high and loading effect of the devices would be very nominal compared with the electrical measuring instruments. Electrical measuring instruments are also called as VOM meters, volt ohm meters. Then, electronic instruments are broadly classified into transistor type electronic voltmeters, that is TEVM, and FET type electronic voltmeters, FET EVM. Then, what is FET EVM? We have seen FET EVM, its basic circuit arrangement, and its working also. FET EVM is one such electronic voltmeter offering very high input impedance, making use of a range attenuator circuit, that is a potential divider circuit, in combination with a single pole 3-terminal range select switch, is called as range selector circuit, with an FET and a BJT and a bridge network consisting of one BJT and three resistors, out of which one is a potentiometer used for zero adjustment. FET is used in source follower mode, ensuring high input impedance and low output impedance. The output of FET is connected to a BJT, which is used in emitter follower mode. This also provides high input impedance and low output impedance. So the combination of FET used in source follower followed by a BJT used in emitter follower increases the input impedance by a large amount. ensuring the sensitivity of the device to be very high and loading effect is nominal. The next one is differential voltmeter. Differential voltmeter also is an electronic type voltmeter. It is the most accurate method of measuring unknown resistance. The voltmeter is used to indicate the difference between the unknown voltage and known reference voltage. Here is the basic circuit arrangement used in a differential voltmeter. As you can see in the circuit, the unknown voltage is connected to the terminals of the differential voltmeter. It is shown on the left portion, left side, the dotted block, unknown voltage, that is a portion of the network where we want to measure the voltage of the internal resistance. The resistance also is shown because the portion of the network is basically a resistor or any other combination of components exhibiting some resistance across which we need to measure the voltage. So symbolically it is represented as Ex, that is the unknown voltage across a resistance having an internal value of Rx, and a null indicating meter is used here. The basic principle of the null indicating meter is something like it will indicate the value which is the difference of its two inputs. Actually, its null value would be on the center of the scale. To the left side, the markings will be negative, and to the right side, the markings will be positive. When two voltages are applied to the null detector, depending upon the relative magnitudes of the voltages, the pointer deflects in a direction depending upon which voltage is larger. Suppose if one voltage is larger, the pointer deflects in the counterclockwise direction, let us say, that is towards left, then it will rotate in the clockwise direction or move towards right side when the voltage is, let us suppose that voltages E1 and E2 are applied to the terminals of a null detector, and assume that when E1 is greater than E2, null detector is moving towards right. Then when E1 is less than E2, null detector will move towards left. That is the logic. Center of the scale is 0. Towards left, the scale is marked in negative values, and towards right, the scale is marked in positive values. So that is the principle of null detector. Then a precision potential divider is used in combination with a known reference voltage. In combination with a known reference voltage. As you can see in the circuit, a potential ER, that is reference voltage, is applied across a potentiometer, and the wiper of the potentiometer is connected to one terminal of the null meter. That means the input at the null meter is the potential at the wiper of the potentiometer with respect to the circuit neutral, or with respect to ground, circuit ground. On the other side, that is to the other terminal, the unknown voltage source is connected. Now, depending upon the relative magnitudes of Ex and a fraction of Er, the null detector pointer will move either towards left or towards right. At this juncture, by adjusting the potentiometer, we have to see that the null detector indicate 0. By adjusting the potentiometer in either directions, either by increasing the voltage of the potentiometer or by decreasing the voltage of potentiometer, we have to make sure that the null detector reads 0. It comes to rest at the middle of the scale. In that case, what does it mean? It means that no current is flowing through the null detector. When does it happen? Current does not flow through a meter connected between two terminals when the two terminals are at the same potential. This is the principle in differential voltmeter. When the two terminals of the null detector are at the same potential, there will not be any flow of current in the null detector, and the null detector reads 0. So at this point, we can say that the fraction of the reference voltage, that is the potentiometer voltage, is equal to the unknown voltage, is equal to the unknown voltage. Now, by using any of the voltmeters, we can measure this voltage, the potentiometer voltage, and that is nothing but the voltage of the unknown source, or unknown voltage of the portion of a network. So that is the basic principle employed in differential voltmeter. And one more point to be observed here is, when the two voltages applied to the terminals of null detector are equal, zero current is flowing through the null detector. That indicates infinite input resistance. That means even though the meter is connected across a portion of the network for voltage measurement in that network, the meter is drawing zero current. When does the meter draw zero current? When the meter is offering infinite input impedance. So we can say that differential voltmeter exhibits infinite input impedance, and it measures the unknown input impedance very accurately. 100% accuracy would be there in the measurement of voltage using differential voltmeter. Is that clear? So there will not be any loading of the voltmeter on the network. Basic differential measurement. The differential voltmeter is used to measure an unknown voltage. Here, voltmeter is used to indicate the difference between the unknown voltage and known voltage. In the figure of the null meter, in the figure of the differential voltmeter, the null meter is connected between the unknown voltage source and the output terminals of a voltage divider. Voltage divider is connected across a reference voltage source. In this particular example, it was 4 point, sorry, it is given as ER. According to the figure of differential voltmeter, the divider is adjusted until its output voltage equals the unknown voltage. Null meter indicates 0 volts when the two voltages are equal. In this null condition, the differential voltmeter presents an infinite impedance to the source. The reference source consists of a low voltage DC standard such as 1 volt DC. When measuring high voltage, a high voltage reference supply can be used. It is obvious. The reference voltage has to be definitely very much higher than unknown voltages. Then only a fraction of the reference voltage can be made equal to the unknown voltage. Right? So, for high voltage measurements, we have to use a supply with a high voltage value. But whether it is low voltage measurement or high voltage measurement, the accuracy of measurement would be 100% in this, because the circuit offers, or the voltmeter offers, infinite input impedance to the circuit under test. Next one is AC differential voltmeter. That is differential voltmeter used for AC applications. So in case of AC differential voltmeter, additional circuitry is employed in the original DC potentiometer circuit, in addition to the original DC potentiometer circuit, in order to convert the AC signal into DC. Apart from that, it also includes an AC amplifier and range selector, range control, or input attenuator. So, AC differential voltmeter mainly consists of input attenuator or range selector, followed by an AC amplifier, followed by AC to DC voltmeter. After that, the remaining portion is the circuit of the standard DC differential voltmeter. The principle will be the same here. AC input is applied. Depending upon the magnitude of AC input, it is either attenuated or amplified. Then once again the signal is amplified, then it is converted into a DC signal, and the null meter will respond to the average value of this pulsating DC. When the average value of this pulsating DC is equal to the potentiometer voltage, the null detector reads 0. That is the principle. Principle remains the same. 10.2 shows AC differential voltmeter, that is this one. The AC differential voltmeter is a modification of the DC instrument and incorporates rectifier circuit. The unknown AC voltage is applied to the rectifier for conversion into a DC equivalent to the average value of AC. The resulting DC is then applied to the potentiometric voltmeter. That is, differential voltmeter is also known as potentiometric voltmeter. Differential voltmeters have three modes of operation. In first mode, it can be used as a DC voltage standard, and it can also be used as a DC differential voltmeter, or it can also be used as a simple DC voltmeter. Let us see how a single circuit can be used in three different modes. Differential voltmeter. The instrument generates output voltage from 0 volts to 1000 volts. That is in the first mode, DC voltage standard. Reference figure shows standard mode of operation. Reference supply voltage generates a plus 1 volts DC, which is applied to a decimal divider network. Here this is the circuit arrangement. A commercially available standard differential voltmeter consisting of 1 volt reference supply and a decimal divider. What does it mean? 1 volt is divided into zero point 0.1 volt, 0.2 volt, zero point 0.3, 0.4, 0.5, 0.6, 0.6, 0.7, 0.8, 0.9 and 1 volt. So the input voltage, reference voltage of 1 volts can be converted to any decimal fraction of the voltage according to the requirement by using a potentiometer knob. It can be converted as 0.1 volt or 0.5 volt or zero point 0.3 volt or zero point 0.8 volt. We can convert it to any position. Then low level DC amplifier. This 1 volt itself is very low, and further it is reduced by using the decimal divider. Next stage is that signal is amplified. Say for example we need 30 volts here. Then 1 volt converted to zero point 0.3 multiplied with 100. Right? That is how we get the value here. Low level DC amplifier. That is given to a high gain amplifier. Here an amplifier with high gain is used. Then that is given to the output control stage. Here this output control stage will take care of the exact value of the output. That is, it will see that the output remains exactly at the preset value. And here you can see a feedback from this portion, that is the voltage across 1 volt in this potential divider network. is fed back as input to this low level DC amplifier. Now, depending upon these two voltages, that is, the voltage out from the decimal divider and the voltage from range selector, the difference of these two signals is amplified here, right? The reference, the difference of these two voltages is amplified. Now, here let us see how it works. Let us assume that the voltage required at the output be 1000 volts, standard output. For that case, here this range selector switch would have to be here in 1000 volts range. So the range selector switch is connected to this 1000 volts range. That means the output of the high gain amplifier is applied as input to this potential divider. So you have got four resistors. So obviously the output of high gain amplifier gets divided into four parts. Depending upon the relative magnitudes used for this resistance, let it be R1 and R2, R3 and R4. At the resistance R4, the drop would be taken as feedback, right? Now, as long as the output is at 1000 volts, here there would be some fraction of that 1000 volts. That fraction of 1000 volts is compared with the decimal divider output. So here this is difference. So as long as this is high, maintained at 1000 volts, not exactly high, exactly at 1000 volts, then here the voltage would be a predetermined value. Let it be some E1. And that voltage is amplified to produce 1000 volts. Now, for some reason, if the voltage is reduced at the output, then here at this terminal, the voltage will be lesser than 1000. So here the voltage will be lesser across resistance R4 when compared with the previous value. So the output of low voltage DC amplifier previously it was assumed to be even. Now it will become even plus delta V. Suppose here this value has been reduced. So this minus of minus, it becomes plus. So even plus delta V. That is multiplied with the high gain amplifier. So output of that you will get some another value E2 plus A times, or simply say if the gain of this is A multiplied with E1 plus delta V. Previously, when E1 A times E1 was there, then we have got 1000 volts here. Now here this voltage is reduced. So naturally there was a reduction in the high gain amplifier output. As a result, some error would be generated, positive error. That positive error is amplified. Because of that amplified positive error, the voltage at the potentiometer increases to be A into V1 plus E1 plus delta E or delta V. So obviously the drop across this also increases now. As a result, what happens here? The difference between these two, it will come down. Let us, when the output voltage once again becomes 1000, here you will get some value of E1 once again back, and here it would be some VR, and this minus this, it will have some say ED, difference voltage. As long as the voltage here is ED and the voltage here is E1, output voltage would be 1000. When this either increases beyond 1000 volts or decreases below 1000 volts, then because of the feedback applied, correction keeps on taking place until once again this voltage is brought back to the preset value. So that is how it can be used as a standard DC source, voltage source, that is in first mode. Gain of the amplifier depends on the amount of degenerative feedback. The output terminals of the instrument in the standard mode of operation provide the following voltage ranges: 0 to 1 volt in 0 to 1 volt in 1 microvolt steps, 0 to 10 volts in 10 microvolts steps, 0 to 100 volts in 100 microvolts steps, 0 to 1000 in 1 millivolts steps. Now, the same circuit is added with additional potential divider here, additional potential divider. Actually, this part is the same DC voltage, and here additional circuit is employed. Now, if we see, when the input voltage is applied through range divider and low level amplifier, DC amplifier, high level amplifier, you will get some value here. That voltage can be connected to this position or this position, this position or this position. Here, what happens, these two switches either will be connected here and here, or to 1000 and the corresponding other side, 100 and corresponding other side, 10 volts and the corresponding other side, and 1 volt and the corresponding other side. If you change the position, these two switches as a combination, they will move either up or down, connecting both sides. So, when depending upon the range of the reference voltage used here, because we do not know what exactly is the unknown voltage, we have to change this range selector switch either down or up, and a fraction of that reference voltage is taken and feedback to this differential amplifier, or we say uh, the basic differential voltmeter circuit. Now, by adjusting this position gradually, when this output of the decimal divider equals this potential output of this resistance, then the meter reads 0. When the meter reads 0, it indicates that the potential here at this point is equal to the potential at this point. We may not know the potential at this point, but definitely we know the potential at this point because of the known voltages across the circuit. So directly we can say that, or we can give the value of unknown voltage as the drop across this. So that is how it can be used as a differential voltmeter. Now, without using any this circuit arrangement, without using this one, this can be directly used as a DC voltmeter. Here, in place of null detector, you will have a PMMC movement. The second mode of operation is connected by figure 2. The unknown DC voltage is applied to the input terminals, that is here. To control the closed loop gain, one half of the divider network feeds a fraction of the output back to the input stage, that is this portion is connected back to the input stage, and the second section of the divider network applies the output voltage to the differential input of the null amplifier, that is this portion connected to differential amplifier of the null meter. The meter measures the difference between the feedback voltage and the reference voltage and indicates a null when the two voltages are equal, right? When the two voltages are equal. The range selector of the instrument controls both the feedback voltage and the voltage to the reference divider output. That is what I told. Both the switches are connected together and adjusted by a single position changer. By controlling the position, both the switches will change their positions simultaneously, either up or down. So that is about the standard differential voltmeter, making use of the principle of null detection. And because of this null detection, the input impedance will be very high and loading effect would be almost zero. So differential amplifier produces very high accurate measurements. So this is what we have seen. We have seen differential amplifier, differential voltmeter and its basic circuit, AC differential voltmeter, and differential voltmeter used in standard mode and differential mode. Okay, the next topic is uh, high voltage probe and current probe. That we will see in the next class. Thank you.